everybody. So here I'm going to demonstrate graphing parallel and perpendicular lines. This specific problem is saying graph a line that is parallel to the given line. Determine the slope of the given line and the one you graphed in simplest form. Click and drag. So this can be a little annoying just because it gets picky about clicking and dragging, but the slope part should hopefully be review from what we've worked on in previous weeks. So notice this line is sloped down to the right. Since this function is going down to the right, I know that means our original slope is going to be negative. And the nice thing about finding parallel slopes is that parallel is the exact same slope. So I know my parallel slope is also going to be negative. And now in order to figure out what the slope is, I find any whole coordinate point. In this case, I've seen -6, -5 works, and I'm going to count and see how much it takes for me to go down to the right to the next whole coordinate point. So I see that from -6, -5, I can go down 1 and right 1, 2. So that would be a rise of going down 1, again it being negative, over, I went 2 to the right. So our slope then is going down 1, right 2, so that would give us a slope of -1/2. Our parallel slope will also then be -1/2 because parallel slopes mean exactly the same thing. Now that I've written in what the slopes are, I just have to graph the actual line itself. So what I'll do is I'll click any point. Parallel means they don't intersect. So as long as I make sure I'm not clicking a point on the line, I'm going to click, and then I'm going to actually drag. Notice it'll be a dotted line unless I got the slope right. So here where it's green, that represents a slope of -1/2. Because between my two yellow coordinate points, I go down 1 and right 2. So that is an example of a parallel slope being graphed. Let's check our answer to make sure we were right, and we were. Again, both slopes were -1/2. They did their line in a different place. Doesn't really matter where you show your line. Let me just go through and do one more problem so I can find us a perpendicular. And this is perfect. It's perpendicular. So they want us to graph a line that is perpendicular to the given line. So again, to start out with, I like to look and see is the slope positive or negative. This slope, this graph, is going straight up to the right. So since it is going up to the right, it will have a positive slope. Perpendicular then is going to be the opposite. So I'm actually going to write in here to remind myself that it will be a negative slope because perpendicular is the opposite sign of the original. Now to find the slope of the original, I'm going to find a coordinate point like 1, 0 that's perfectly on the line, and I'm going to count how much I need to go up and to the right. So I need to go up 2 and right 1 to make it to the next whole coordinate point. So again, my rise there would be 2, and my run would be 1. Now, if my slope is 2/1 in simplest form, I can write it as just 2. But it is important to remember that it's technically 2/1 simplified. Because perpendicular needs us to do the reciprocal, or the opposite of 2. So if we flip that fraction of 2/1, that means the perpendicular slope will be -1/2. Again, opposite sign, opposite fraction of the original slope. So our original slope should just be 2. Perpendicular slope -1/2. And the last step here is we're going to have to actually graph the line. Perpendicular means meets at a 90-degree angle or right angle. So I do want to click on a place that will touch my line because I do want to make sure they intersect. So again, I clicked a point that I know works, and then I'm going to have to drag to create my other point. If I drag it out, notice we got lots of dotted lines. Those are in all the places it doesn't work. You can just try your best to kind of see what would be roughly a 90-degree angle. We'll see if it works. And then notice there I had a whole line right there. When it's a solid green line, that means that it works. And again, if you don't want to just guess where the line is, just follow the slope. That means that we would go, if we were going in reverse, left 2 and up 1, or down 1 and right 2. So those would be our two perpendicular lines. Our slopes are 2 and -1/2. If we submit the answer, let's check and make sure we're right. We are all set. Slope of 2, perpendicular slope being -1/2, and they did their line again in a different spot. Many possible perpendicular lines can be made. Hope this was helpful. Thanks so much.